Welcome to Dr. Yeap Ban Har's Problem Box. In today's lesson, we are going to solve a problem. Let's see what problem we have for today. Today's problem doesn't fit into the box actually, but they do fit onto my shelves. It's about the way the books on my shelf are arranged. Here I have 7 books, numbered 1 to 7. 1, 2, 3, 4, 5, 6, 7. And this is one arrangement. The problem is, how many different arrangements are possible with 7 books? Have you managed to solve the problem? How far are you in trying to solve the problem? We can try to solve a simpler problem. For example, what if there are only 3 books, numbered 1, 2, and 3? So this is one arrangement, 1, 2, 3. And I think I can also arrange it as 1, 3, 2. That's 2 arrangement. So with the first book being 1, I think that's it. So I'll try possibilities that start with book 2, 2, 1, 3. But I can switch the 1 and the 3 to get another arrangement, 2, 3, 1. Of course, I can start the arrangement with book 3. So 3, 2, 1 is yet another different arrangement. And 3, 1, 2. So far I've gotten 6 different arrangements. Let's organize our thinking. So we can try to solve simpler problems with different number of books. And then try to see how many different arrangements we can get. With 1 book, that's pretty easy. With 2 books, book 1 and book 2, I can have that arrangement, 1, 2, but I can also have 2, 1. Anything else is possible? If not, with 2 books, I have 2 possible arrangements. With 3 books, we have tried and we got 6 arrangements. Remember? Can you predict how many arrangements are possible with 4 books? And perhaps you can see a pattern and use that pattern to solve today's problem. What's the answer? Did you manage to try to find the solutions to the simpler problem of having 4 books or 5 books and so on, and then use that to solve the main problem? Do you think you managed to see a problem? One book, one possible arrangement, two books, two possible arrangements, three books, six possible arrangements, and four books, 24 possible arrangements. I don't think I want to try to write out the possibilities with 5 books. I think there will be way too many possibilities. So let me try to get the answer not by doing, but by thinking. Is there a pattern that I can see? I suppose 2 is 1 times 2. Six seems like it can be 1 times 2 times 3. So if my pattern is correct, the next one would be 1 times 2 times 3 times 4. Is the product 24? Oh, yes it is. So I think that pattern works. With 5 books, possible number of ways would be 1 times 2 times 3 times 4 times 5. And I think I know the answer to our problem. How many arrangements are there altogether? The number of arrangement is also the product when I multiply from 1 to 7. In other words, 1 times 2 times 3 times 4 times 5 times 6 times 7. That product is the number of possible arrangements with 7 books. If you find today's problem easy, you can challenge yourself. One way to challenge ourselves is to explain why that pattern works. 3 books, we multiply from 1 to 3. 1 times 2 times 3. With 4 books, we start with 1, we multiply until 4. 1 times 2 times 3 times 4. Why does it work? Where does a 4 come from? It seems like we have many ways starting with book number 1. We also have many ways starting with book number 2. And many ways starting with book number 3. And so many ways with the first book being book number 4. Do you think you can explain why the pattern is like so? With 4 books, we start with 1, we end with 4. 1 times 2 times 3 times 4. Why 4? Other than trying to explain why the pattern or the formula works, another way to challenge ourselves is to go around looking for other things around us that is based on the idea that we were dealing with in today's problem. For example, in suitcases, this is an old one, we have combination locks. How does a combination lock works? When you put in the correct arrangement of digits, you can unlock the bag. Some suitcases have 1 such lock, but this one, there are 2. That means you need the correct arrangement to unlock this side, and you also need the correct arrangement of digits to unlock that side. Of course, the arrangement of digits could be the same, but they don't have to be. We can also challenge ourselves by looking for things around us that make use of ideas of arrangement. And we can pose problems. For example, how many possible arrangements of digits we can have here? We all know digits go from 0 to 9. And here there are 3 digits. How many possible digit combinations are there? In other words, what's the chance of a person guessing randomly, getting it right? And what if that person uses different arrangement of digits here and here? What is then the chance of a person guessing randomly able to open this suitcase? We can also challenge ourselves by looking for situations around us that make use of the idea of arrangement. Arranging books, arranging digits, arranging people, and so on. Those are at least 2 different ways we can challenge ourselves. See you next time in another problem box.